Welcome to Lewis structure and exceptions to the octet rule. So a Lewis structure shows how the valence electrons are arranged among atoms in a molecule. Now ionic compounds, remember, have one or more valence electrons transferred from one atom to another. So this is things like potassium bromide, where the potassium has lost an electron and the bromine has gained an electron. Magnesium chloride, where the magnesium has lost 2 electrons, 1 to each of 2 chlorine atoms. Covalent compounds, on the other hand, have 2 or more valence electrons that are shared between atoms. So these are things like hydrogen gas, or fluorine gas, or water, or methane. Now, to write a Lewis structure, first we need to figure out how many valence electrons there are. So first we sum the valence electrons from all of the atoms. We're not interested in the core electrons. We only care about the valence electrons, because those are the ones that are involved in chemical bonding. Those are the ones that we need to take into account. So then we use a pair of electrons to form a bond between each pair of bound atoms, and then arrange the remaining electrons to satisfy the octet rule for all of the atoms, bearing in mind that some of the atoms are exceptions to the octet rule that we'll talk about later in the video. So let's look at cyanide, Cn-. So this is one of our polyatomic ions. So let's see, carbon starts out with 4 valence electrons. So we start with 4, nitrogen starts out with 5, and this -1 charge on the polyatomic ion means we've added 1 electron, so we have to add 1. So overall, we have 10 electrons total. So we need to draw a structure with 10 electrons, 10 valence electrons, right? There are some core electrons involved, but we're not interested in those, we're going to ignore those. So now we want to write our 2 atoms together. We have carbon, we have nitrogen, we want to put 2 electrons in between the 2. So we'll start there. And now we need to add in the remaining 8 of our electrons. So let's start by adding some electrons around the more electronegative element. Now which one is more electronegative? The nitrogen. So let's add some electrons on the nitrogen. So now we've satisfied the octet rule for the nitrogen. And we have 8 electrons in there. We need 10, so I can put in 2 more. So I'll put in 2 more over here on the carbon. So the nitrogen, we've satisfied the octet rule, but the carbon, we haven't. So if I take 2 of these electrons and move them over there, well, now I'll be closer to satisfying the octet rule for the carbon. I'll have 6 valence electrons there instead of 4. But I still won't, then I'll have ruined the octet for nitrogen. So we need to move these electrons in such a way that we give them to the carbon, but not removing them from the nitrogen, which means they need to be shared. So I'm going to take 2 of these electrons, and I'll put them in here. So now we're sharing 4 electrons. Now the carbon has 6 valence electrons, and the nitrogen still has 8. But the carbon still doesn't have its full octet, so we need to share another pair of electrons. So I'll take these 2 and put those in between as well. So now we're sharing 6 electrons, which means now we have a triple bond. We have 2 electrons over here and 2 electrons over there. So we've got a lone pair on the carbon and a lone pair on the nitrogen. But this doesn't show that there's a negative charge. So overall, we need to draw some brackets around the whole thing and show that on the whole polyatomic ion, there's a charge of -1. So another way that we could represent this would be, again, drawing our brackets, have our carbon and nitrogen, and draw 3 lines, 1 line for each pair of electrons, and then add in our valence electrons and our charge. So this is really what a Lewis dot structure looks like, but sometimes people sort of make a shorthand version that looks like this with the lines instead. Either one is really okay, because either one really shows what's going on, as long as you make it clear that you're using lines here instead of dots for electrons. So let's look at some exceptions to the octet rule. So boron tends to form compounds in which boron only has 6 valence electrons instead of 8. Sulfur can sometimes have 12 valence electrons, as it does in sulfur hexafluoride, but it doesn't always. Right? So it doesn't have to have 12 valence electrons, just like boron doesn't have to have 6 valence electrons. Phosphorus can have 10 valence electrons, as it does in phosphorus pentachloride. So that was Lewis structures and exceptions to the octet.